Hey everyone, so in this video I'm going to talk about higher order derivatives. I'm not going to spend way too much time on this because it's not a new concept. You already know the basics for it. You already know how to take the derivative of a polynomial, and basically you can apply the same principles of higher order derivatives to derivatives of trig functions, polynomials, product of two functions, divisions of two functions, basically anything. So I'm only going to do one video on higher order derivatives. So basically, let's just start. Okay, so if I have some function f of x, and let's say it's equal to 100 x to the 100, okay, plus um, 9x squared minus 10x uh, plus x to the square root of x, the whole function cubed. Okay, so if that's my case, then what's the second derivative of the function? Okay, so when I say higher order, I mean this is order, and then this will be, we'll just do like a notation over here. Okay, so if I have, let's say, first order derivative, which is the derivative that you know so far, okay, and the notation for that is d dx, or it has other notations as well, but these are the most common ones. This will be f prime of x. Okay, now if I have something like a second derivative, what's the second derivative of this function? Well, in general, it's basically the derivative of the derivative. So this right here has the notation of d squared, dx squared, and then, or it's just denoted as prime prime of x. There's two tick marks. Okay, so if I say I want the fifth derivative, generally I wouldn't write like 5 tick marks. I wouldn't do f1, 2, 3, 4, 5x because that becomes way too messy for me to read. So basically, after the third order derivative, um, we write d cubed, or actually I don't know exactly what we need to write, but that doesn't matter. Um, we will generally stop with the primes on the top after the third one, and so fourth and the fifth one we'll just write the words out. So if this is the fifth order, then I denote it down as f, and then in little parentheses I'll have a 5 over here, and then of x on the bottom. Okay, so in general, if it's the nth order derivative, okay, what I'll do is I'll have f, and then I'll have n over here, and then of x. Okay, so that's pretty it's pretty intuitive. It makes sense logically, hopefully. So let's say I want to figure out the second derivative of this function. So find f prime prime of x. So the first thing that I need to do is figure out what f prime of x is, because the second derivative is the derivative of the derivative. So f prime of x is equal to, we go term by term, we keep the coefficient 100, bring down the exponent, will be 100, keep the x, get rid of 1 from the 100, so it'll be 99, 99, plus, keep the coefficient, bring down the 2, keep the x, take 1 away from the top, so that'll just be 1, right? So I'm not going to rewrite that. Take the minus, derivative of 10x, you'll get the hang of it, it's just 10, keep the plus, keep the x, bring down the exponent, keep the coefficient, which is 1, right? Now, previous video, or a couple of videos back, we saw that square root of x is the same thing as saying x to the 1/2. So if this is x to the 1/2, the whole thing cubed, this right here is the same thing as saying x to the 3/2, right? So now, I'm going to bring down the 1/2 I didn't bring down from the top over here. So I'll have a 2 over here, and then this will be x to the 3/2 minus 1. Well, 3/2 minus 1. Simplify this up a little bit. So this will be 100, 0, 0, x to the 99, plus 18x, minus 10, plus 3/2 x to the, what is 3/2 minus 1? That's 1/2, right? So that's it. That's the first derivative. Now, let's see what the second derivative is. Second derivative is the derivative of the derivative, so it's right here. So I'll keep the coefficient 100, 0, 0, bring down the 99, keep the x, take 1 away from the 99, I'm left with 98. The plus stays the same, derivative of 18x is 18, derivative of negative 10, well, negative 10 is a constant, so it'll be 0, so I'm not even going to write this, I'm just going to put a 0 over here. Plus, keep the 3 halves, bring down the 1 half, keep the x, take 1 away from the 1 half, so 1 half minus 1. So what's my derivative of the derivative, which is the thing that I'm trying to find? So f prime prime of x is 99, 0, 0, 0, 0, x to the 98 plus 18 plus, what's 3 halves times 1 half? Well, it's 3 over 4, right? Times x to the negative 1 half. So that's it. This right here, I mean, if you want to simplify this term, and instead of saying 3/4 x to the negative 1 half, you could have written this as 3 over 4 square root of x. Okay, but this really isn't necessary. If you got this far, you get the idea. So let's do one more quick example on the next slide. So let's say I have this function f of x, and I'm going to do a simple function, okay, just so you get the hang of it. Let's say I have 10x to the 85. Well, I mean, 85 isn't really a simple function, but yeah, you'll get the hang of it. So what is f3 of x? Okay, so this right here, if you just go back to the last slide, you'll figure out that this right here is a third derivative of the function. Okay, so I'm going to start with the first derivative. So f prime of x is equal to, keep the coefficient, bring down the 85, keep the x, take away 1 from the 85, so it's 84. So what is f prime prime of x now? Well, f prime prime of x, keep the 10 and the 85. I'll simplify it in the last step if I need to. So 10, 85, keep the x, get rid of 1 from the top, so 83. Similarly, hopefully you got the hang of it by now, f prime prime of x is the same thing as saying f3 of x, right? And this right here is just keep the two, whoops, I made a mistake over here, I didn't bring down the 84. Hopefully I said to bring down the 84, okay? So we'll keep this over here, so it'll be 10 times 85 times 84 times x, take away 1 from the top, so it's 83 minus 1, which is equal to 82. So, I'm not gonna calculate this. I mean, I don't think I have the mental capacity to calculate this, but basically, I don't know, if you have a calculator, just do it. If not, I'm just gonna write this as some constant, right? So it'll be some number. It's up to you to calculate this product, that coefficient. So number times x to the 82. So that's my third derivative, okay? So hopefully you got the hang of the higher order derivative, and that's the same thing, okay? If you're trying to figure out the derivative for a trig function, okay, so it's gonna be the same thing. A higher order derivative is just a derivative of a derivative of a derivative until you get to the order that you want to. Okay, so that's it for this one. Good luck. See you in the next one.